It is related to the loss calculation in the transient magnetic problem. This task is more complicated than losses calculation in AC magnetics. In AC magnetics, there is the empirical equation which is based on the frequency of the sinusoidal changing flux density and the flux density peak value. In transient problem, the diversity of the signals prohibit using the universal equation for all cases. That's why we didn't implement losses calculation in transient problem in QuickField. Instead, we offer the custom integral functionality. In many cases, in transient problem, you cannot say what the frequency are and what the flux density value should be used. So we will consider the simple case, the transient problem with sinusoidal excitation current. It's the same problem I described in the previous case. This is the single phase transformer. In no load mode, there is only the current in the primary winding and there is no current in the secondary winding. Now let's start QuickField and take a look at the problem. I will open the geometry model. Here is the same geometry model and there are the same objects in this model. The problem type is transient magnetics, so there is no specific frequency in this problem. Instead, I specified the timing, the total calculation time and the time step. As I said, for the transient problem, you cannot calculate losses inside QuickField, so there is no tab with core loss calculation coefficient. For the winding in transient problem, you should type in the full equation, which includes the 400 is the number of turns multiplied by the current value multiplied by the sinusoidal function two multiplied by p 180 degrees multiplied by frequency multiplied by time. So this is the sinusoidal function of the current changing in the primary winding and the same function with negative in the other part of the coil. Now let's run the simulation. The results include the field distribution for every time step specified in the problem properties, and you can see how the field values changed in time. For example, here how the current density changed in time. Now, to use the Bertotti expression, we need to adjust the field picture so the peak value of the flux density is displayed, which would be about 0.625. So I will adjust the field picture. Now I will select the integration area And now I will use the custom integral. The custom function is the same which is implemented in QuickField for AC magnetics, so I can expect to get the same values as in AC magnetic problem. Now let's check AC magnetic problem. Here is the result that was calculated in AC magnetics. And now I will run the calculation for transient magnetics. After about 1 minute waiting, we get the value, which is 0.1447, and in AC magnetics it was 0.146. So there is the slight difference in loss calculation in AC magnetics and in transient magnetics using custom function. Now let's take a look at the code which is implemented inside this Excel file. I will follow to developer and open the Visual Basic editor. The program consists of two modules, the module and the class module. First about the class module. The class module is the function which calculates the custom integral. The input parameter is the field point data, the field data in mesh node in QuickField. Remember, QuickField send the field data in the mesh node. So here is the function that gets the field data from QuickField. This function extracts the flux density, the peak value of the flux density, and put it in the Excel cell. In this cell. Inside Excel, the loss value is calculated for the flux density, and the resulting value is sent back to QuickField. So here you can see that I get the cell value and send it back to QuickField. Now that's all the code that QuickField needs to calculate the custom function. In this module is the code that is required to call QuickField from Excel. There are the following string. We create the link to the QuickField application. We get the link, get the active problem. We get the result. In the result window, we get the integration contour. And then we ask QuickField to calculate the custom integral. And the resulting value is then put back in the Excel. You see the code is very simple, you can modify it for your convenience. There are both versions for the transient magnetics and for the AC magnetics.